Yeah, so let's try to increase the bus factor on Makie's layout system a little bit. Explaining how it works. So yeah, this is supposed to be a little more looking at the technical parts of how the layout system works and where it comes from and what it can and cannot do. So if in the future you interact with it, you hopefully know more about what's going on than you do now. Okay, so first the question, why do we or why did Makie even need a good layout system in the first place? So like for me, it's mostly the aesthetic parts of visualization that cannot really be overemphasized because I mean we are like these visual creatures, we see information and I think we can just perceive it more clearly, more quickly if it's well organized and ordered, and we pick up on structure and grouping and alignment, and that's why it's important that things are correctly aligned so that you can infer like what belongs together and what's important and what isn't. So it's not just like being perfectionist about like font placement or whatever, but it's really about like a basic quality of the visualization, which I always cared a lot about, which is how I even got to this to this project of implementing the whole system for Makie. Right, then it's really just a time issue also, like because a lot of people, especially some years ago, were really spending a lot of time manually adjusting their plots, like with the tiniest aspects, going round tripping with Illustrator or Inkscape or other programs. And yeah, this is always just so time consuming, especially if you have to make any changes, all your manual adjustments are wasted basically. And I really hated that practice. And I was one of the people while I was still at university that would over engineer the code of their figures. So I would never have to do that, but I would just have to write that much more code to do it. So the question was really like, was I saving time? Was this just like I was just really, really trying to avoid the manual labor, but yeah, I don't know, still it was a hard problem. And so a layout system for me also has to cover a wide variety of situations. So when I started with this work on Makie, like one of my first ideas was, it's kind of silly, but I was like, the color bar is not allowed to just stick to the axis, because I was like, once you decide such a thing like an axis and the color bar, they always belong together and they form that kind of this unit, and the color bar is not really its own thing anymore, then you lose a lot of flexibility. And a lot of plotting software, I think, it just goes this way of the most commonly found objects. They are just kind of placed together, and not everything stands on its own and can be placed wherever you want. And so that was one of the reasons I designed the thing as it is, because I wanted every object to be freely placeable wherever you want, with a lot of freedom to still decide how the layout solves. And so yeah, the history of the layout system in Makie was such that first it was just this bounding box system where you would stick together scenes. I mean, yeah, those who work with like a little bit low level Makie know about scenes. You don't have to interact with them anymore in base Makie, but that's like the basic unit of the frame that you can have in your figure, a rectangular area that contains plot primitives. And at first it was just like you could stick them together in like a vertical or horizontal fashion. But this meant that the bounding boxes of the scenes, they would be aligned, but not the content itself. So you can see here that there are all sorts of issues, like for example, this line here is different from the line below it, because the scene probably stops here and the other one here, but yeah, the content actually, it looks kind of off. Then you have issues with label placement, it's kind of tight around here, or this title has sunk into the figure, all this kind of fun stuff. So that was the state of Makie when I joined. And so my first idea was attempting to use a constraint solver, because at the time I was a heavy matplotlib user, and they had added a constraint based layout sometime earlier. The problem with that was that I could not make it do what I wanted in very specific circumstances. Like I wanted to place labels in weird places in the figure, and wanted to have stuff adjust to it and so on. And I was just always fighting against their model, the hierarchical model of organization, where you didn't really know how things in this constrained layout interacted with each other. And so I thought maybe I can port something like that to Julia. And that was also one of the first open source contributions I tried in that ecosystem, was to port the Kiwi solver, which is the backend of Matplotlib, as far as I remember, to port that, or port the version of it, which was called Julia, to Julia, and attach that somehow to Makie and make things render with that. And yeah, this is like an image I generated at that point, which I think was also like the first issue or first PR I made to Makie years ago, where I tried to have like this box model in, like you have boxes in grids, and they have different, yeah, those were already those diffusion kind of things that I came up with, where I thought the inner parts usually of these boxes should align, and whatever is outside of it is just part of the column gaps. That was like the main idea. That is still like the driver behind how the layout works. You have an inner part and you have an outer part, and usually you know how large the outer part is because it's some text for an axis, like a title or X label or stuff like that. And the inner part is what can be freely distributed, and what aligns itself, or like the content there rescales to however you squish or stretch it. So that one can be freely placed. And it, as you can see, like it could already solve these kind of layouts in a way that I wanted to, but there were just random failures of solving these layouts, which I couldn't really debug, because a constraint solver like that, you just feed hundreds of variables into it. You say like this line is supposed to be where this line ends, and you know these things are supposed to be that wide, and all of that, and the thing just does its magic, and in the end it spits out values for all your variables, but you don't know what you can do about it. And if it fails, you don't really have much of recourse. And so I did abandon that approach after a while, after hacking on it. And then I thought, okay, actually, most of the problem is not really, it doesn't really call for like an optimization procedure, but it can really be deterministically solved, just computed where everything is supposed to be if you give a couple of specifications. And that was then the idea behind this grid algorithm in grid layout layers, how it's now. Or at first it was called Makie layout for those who and then it was split out into its own package. And yeah, then with that already, this figure is already a couple of years old. And then pretty quickly you could actually do these very complex plots with grid layouts that solve most of the overlap issues that we were facing before. So from that point on, yeah, you could use Makie in a very different way and do much more high quality figures with it. I remember Simon, like after the first couple, I think about this kind of thing, you said like, this, for me, this doesn't even look like Makie anymore, because you were just used to this other thing for years, and now suddenly it had like this very solid look, which I was very happy about. Right, so let's go into like how this thing works. The design is that it revolves around this grid layout object, and it's hierarchically organized. So a grid layout has a bunch of children, which are like these grid content objects, and these grid content objects, they wrap whatever the real object is that participates in the layout. So you have like, it's like type hiding, right? You put that layout in the object, like an axis or color bar, you put it into the grid content, but for the sake of the grid layout, what the real object is doesn't matter. It just communicates a couple of metrics to the layout, which are used for solving. And it's all working through observables as well. So whenever you change a part in this whole layout system, then it bubbles up the hierarchy. And so this, like you can see that this this is supposed to visualize that we have like a vector of things here in the child vector of the grid layout. So one thing that people are sometimes confused about when starting with the layout in Makie is that they expect, because of the syntax with the get index, like, I don't know, big and then square brackets 1,1, that looks like matrix notation. And so they kind of expect something to be stored in a matrix. And they expect, for example, that only one object can ever be at one position. But it's really not at all like that. It's just that every object, every grid content just has its own span field, which says like what rows and what columns it covers, and a side field. And the side is usually inner, which means that if you have a layout and you have cell number 1, then if you place an object at the inner side, it just covers like this cell. But you've probably seen that you can place stuff into these side areas as well, which is really helpful for aligning like labels over axes or whatever without them needing their own little row in the layout. Right, so you have this vector of content, and you could, I don't know, you could have 10 axes that are all at position 1, 1, and it would look bad, but the layout doesn't care. It just determines what object has like the maximum dimensions at any place, and accumulates that into the final solve. So yeah, it's really not a matrix. And yeah, this whole thing can just nest arbitrary many levels. So another grid layout could have again the grid content with an axis. So say yeah, it's like a tree of layout objects. And so yeah, the update mechanism. I wanted to show what kind of observables are participating there, because I think that's also sometimes a little bit opaque, like what's going on, how these updates travel, and especially if you have problems with multiple updates, which is a very common thing with the observable workflow. So I wanted to go over how that works as well. So yeah, here are a couple of the basic observables that you might know about. So I colored them blue if they are usually set by the user. So you might know, like, I don't know, you can give an axis a width of 300, or you can set this. You probably had a lot of fun with tell width and tell height. So those are also common to set, and the align mode as well. The outer size and the protrusions are usually set not by the user, but by the object, like an axis. It computes its own protrusion by checking like how tall is the title, or how wide are the axis labels and so on. Okay, and so these observables, they all feed into this one thing, which is like the reported dimensions. And I copied the definition of that here. Optional is just like a union nothing. For some reason, I liked that better at the time. So yeah, the dimensions of one object in the layout, they're made out of the inner part, which is like a width and a height, but both of them can be nothing. So and the outer part is this rect sides object, which is just 4 values, like left, right, bottom, and top, and those always have to be numbers. So that's like one of the parts of this layout. The outer parts of an object, the protrusion values, they always have to be known, but the inner parts can be unknown. And depending on how those are, the layout solves the positions. Then from this dimensions value, if an object is not a child of another grid layout, so that would be like a parent grid layout, then it communicates these dimensions to its like computed bounding box, and that's the actual bounding box in the figure where the object ends up in the end. Right, that's the and you might have seen some code that I posted like on Discord or so, where I tap into that observable to do some placement. So that's, yeah, if you want to know where an object ends up after the layout solves for its position, that's the thing, like the computed bounding box. Right. And there are 2 other things that feed into that, which are the horizontal align and the vertical align, as well as the suggested bounding box. So that's one difference, like the suggested bounding box just says like, you may place yourself in this particular area, but depending on how the object itself aligns itself and what size it computed for itself, it does not have to take all the available space, right? You can imagine, for example, a label which is only like, I don't know, 50 units wide, but it has a space across the whole figure assigned to it, like all the columns, and then it might get a bounding box with, I don't know, 400 units width, and then depending on its horizontal align value, it will then place its computed bounding box somewhere in this space that it was given. Okay, right. And so the suggested bounding box is usually also not controlled by the user, and it's usually controlled by the layout. Like that's the thing, when the layout solves itself, that's the observable it sets on the child element. It says like I suggest you place yourself here and you there and so on. Those are all the boxes in the grid that appear. Okay, then if this object is actually a child of another grid layout, then it tells its parent to update its own layout basically. So this is how the information bubbles up. Like some label changes its width, and then it says to the parent layout something about my dimensions changed, and then that parent layout solves itself and checks if its own width is now known or not. And if that value changed to what it was previously, then it also communicates that to its parent. So that's one nice thing about the layout, is that parts of it can solve themselves like independently of the rest. So if you have a lot of stuff going on and you only change a label width and some sub layout on somewhere on the left or whatever, if it doesn't have to affect the parent layout, it won't. That's kind of a nice aspect, but it also makes like the flow of information a little harder to follow sometimes. When you ask yourself, why is this information not passing through, it might be that it was swallowed like on the way to the parent grid layout. And yes, basically like when the parent solves itself, it then again updates the suggested bounding box for all the grid content elements, and that this is like where this connection comes in, right? What I said before, the suggested bounding box is usually set by the parent grid, and it doesn't have to be. You might have seen at some point that you can place objects wherever you want by using like the bbox keyword argument, and that's exactly that. I mean, it's named differently because like suggested bounding box feel like an internal name of grid layout based. So this bbox argument, for example, an axis or color bar, whatever, if you have ever used it, that's what you can use to place an object outside of any grid. Like then you just decide where it's supposed to go. And this is nice, for example, if you want to place, I don't know, inset axes or so. You could, for example, say, yeah, like an easy way to implement an inset axis manually would be to go and say, I check the computed bounding box of the parent axis, and then I know where it is. You can do that another way as well, but not just for the example of it. And then I compute, I take this value and transform it somehow into the suggested bounding box of the inset axis. And I don't know, let's say I give the width and the height are both like 50 units or whatever, and then I decide using horizontal line and vertical line where it actually ends up, like if it snaps to the left of the parent axis or to the top or anything like that. So yeah, that's how you can use these observables. So you can see there are a lot of them interacting in this way, and it did take some time to remove most of like the redundant updates in this process. But yeah, that's how it currently looks in the internals. And yeah, because I think Makie has always been kind of like hackable, so sometimes for a given purpose, it's really useful to be able to tap into these specific observables and do something with the data contained there. But it can be challenging to make the whole thing like robust. So usually it's best to just stick with the Fisher API and placing things in grid layouts, because then the whole observable cleanup and so on is done automatically. But yeah, they're there for you to take if you have very specific demands. Okay, so then about the layout solving, just like roughly how does it work? So first of all, like you go through the algorithm goes through the columns and through the rows, and each of the columns and the rows has its own size attribute. And there are different modes of these sizes. So you, for example, you can have a fixed size. You can say like the column always is supposed to be 100 units wide, or you can say it's supposed to be always 30% of the parent layout. That would be a relative size. And they're like auto-sized rows and columns. And that's one thing that only appeared for me after I had written the thing and put it out into the wild and so on. I feel like almost nobody is using like the fixed and relative stuff. Like everybody's just relying on these auto-sized columns, which I hadn't imagined at first that it would work relatively well, so that people would almost never have to interact with this layer. But it doesn't matter for aspect ratios, and so that will come in a second. Okay, so what are determinable auto-sized rows and columns? You can just imagine that the layout checks, I don't know, are there any elements that only span column 1, right? And then maybe it finds a label there and it checks like, okay, is the width of this thing known? And then the label says, yeah, I'm 50 units wide. And then, okay, the layout says, okay, at least 50 units for this column. And then it finds an even larger label, one cell down, and it says like, okay, now it's 80 units or whatever. And then if it finds specific values, it can determine its own size and then will snap to that, basically. And as you all know this issue, that you place a label somewhere and then it squishes all the other content down. That's because an axis by default, it just says like, yeah, size me however you want. I don't care. But a label with a fixed width or height, it will usually collapse these columns or rows that it's placed in. So if you don't want this auto size to be communicated to the layout, that's when you say set these tell width and tell height observables, right? And take a step back. So auto size would be a label internally can check using like the free type API. It can check how large is this label given a certain font and font size and so on. And then it will always be able to compute its own size, right? But you don't always want it to influence the layout in that way. So like that's the interaction of this auto size thing here and the tell width, tell height. It's basically if tell width is false, then the first inner value is just set to nothing, right? No matter what the auto size is, because for label the auto size will always be known. That's not generally the case for any kind of object. But that's what it does. It just hides in this dimension structure. It just hides that the width or the height is known, and then the layout proceeds as if that's just an arbitrary object. And that's how you get these columns or rows to unshrink again. Okay, then the next step is to compute aspect-sized rows and columns, and so an aspect-sized column works like this. You give a reference row if it's a column that you size, or you give a reference column if it's a row that you size, because aspect ratio is obviously always about the other dimension. And then you say, okay, I want this column, the first column always to be in a ratio of 1-to-1 with the first row. And this obviously only works if at some point it can be determined what the height of the first row is, right? Otherwise, you cannot really determine what the corresponding ratio is going to be. So in the first step, the aspect size row or column has to refer on the other side to either a fixed, a relative, or a determinable auto size row or column, because otherwise at this point in the algorithm, it won't know like what to resolve to. And I think that almost never happens to people that they get this error, because like I have not seen people talk about like ask me about it. So it seems really rare that people do like multi-aspect ratio stuff. Usually it's just one thing that they want, maybe. But yeah, okay. Some people might have seen it. But yeah, that might be the reason. If you get an error there, that the algorithm just doesn't know how to proceed, because the things you want aspect ratios to, with are not themselves known in size. And then the last step is to compute all the auto-sized rows and columns where the width could not be determined. And this has the additional step that you can set like a ratio. So you can, if a column has its width set with auto 2, that means that at this the last stage where only the remaining space has to be divided between all the auto columns that are not determined, then you can give a weight of 2 to the remaining columns. And so that's also kind of a way to achieve ratios between parts in the layout by giving like one column auto 1 and one column auto 2, and then no matter how it solves, the second column will always be this double the width of the first. Yeah, that's the layout solving. So you can see it's like a straightforward deterministic algorithm. So if it doesn't work, like it's easy to check why not. And for me, after this, struggling with this black box constraint solver for a while, it was much nicer to work this way. And it seems so far to have solved a lot of people's layout problems. Of course, there's a class of issues that come with that and things that are not so easy. And so, yeah, one more thing I wanted to show are these align modes. So this is like the default align mode that an object gets, which is called inside. And so if you don't set an align mode, that's usually what it is set to. And this means that, like, if we see, this is a whole column in the layout, like with the dashed lines, and this is a whole row in the layout. And if you place an object with inside align mode, it will put its inner area right where the row and the column intersects, like this rectangle. And then the protrusions will kind of go into the column gaps. And there's the additional, like the column gap value that we set is what is between the right protrusions of this column and between the left protrusions of the gap column. Right, so the actual gap between the real columns is larger. It includes these protrusions, but yeah, that's how it's usually set up, and that's how you get alignment of multiple axes along their like leading lines, because yeah, the first axis we have it down here, and then the next one here, no matter how large the protrusions at the sides are going to be. So that's what usually works, but sometimes you need it a little bit differently. And the most common case is the outside align mode, in which case all the protrusions are just placed inside this default rectangle, right? You can see in comparison, now the protrusions are not part of like the gap area anymore, but are like inside the cell. And this is sometimes necessary. Yeah, if for some reason you don't want the text, like for example, we have very long Y labels, and it actually looks bad if the column gap gets so large because the protrusions are inside it. And then you can set the outside align mode, and now the aligning line to the next axis will be along the outer edge of the Y labels. So, and then there's mixtures of that, which is like, for example, in the mixed align mode, you can decide for each of these protrusions manually if it's supposed to be outside or inside. And yeah, those are like for really special cases, but it seems to come up quite often. At least I answered a bunch of questions about it. So yeah, that's like where it goes into the tweaking territory, but still this, I think, saves you a lot of work of manually aligning things. Okay, so now let's go over some of the caveats of this approach, which you probably know already, some of them. So yeah, let's say you have a very large X on an axis, and people ask me like, why does this axis not get pushed to the side? And the thing is that the width of the content in the lower protrusion of this axis just completely ignored. It's like the lower protrusion is just about the height. So nobody checks if something goes into this area. And the reason why not is because, as I said before, the protrusions have to be fixed value. So they cannot change depending on how the rest of the layout behaves. But if you imagine the extent to which this label extends over the axis line here, it depends on how wide the axis is, because like this area here will, this area here will get larger or smaller depending on if you squish or extend the axis, right? And so in this kind of layout algorithm that we have, you cannot include this kind of technical information. And yeah, so it relies a little bit on that usually not being such a big problem. But yeah, sometimes that's just not true. And then you do have to go into tweaking mode a little bit and maybe, for example, manually increase the column gap here. So yeah, that's one of the caveats. The next one is pretty similar, but it's just a different demonstration of that. So let's say you have a label on a 3D axis, and then you can see in this, like with this azimuth setting here, the label fits into kind of the cell. The cell for the axis is given in gray, so that would be the space that it has in this layout. And here it fits, and here it doesn't fit, and it's just about this rotation. But again, if you squish the cell that the axis is in, this whole thing will kind of relay out, and the label will shift again. So it's like a more complex relationship of how far it sticks out. And the layout wouldn't be perfect if I just increased the protrusion value of this cell here by exactly this amount. I mean, it would probably be closer, but it would not be exact because it changes again the moment that we resolve. So yeah, that's another thing. And this is also why the axis 3, which you might have noticed, it doesn't have automatic protrusions like the axis, because it can't really be done. Like, you would have to change it all the time when rotating, and that would look pretty strange. Like if you rotated in every tiny bit of degree change, the whole layout would kind of shift. And you do have that a little bit with axes, where if you zoom in and the tick labels change, it does readjust after like a 300 millisecond or so delay. And I also don't particularly like that, but it seemed like the most straightforward way to not have people end up with really wrong protrusion values for their labels, because then, I don't know, ticks extend out of the figure suddenly if you have larger values there. And you could see it actually in one of the GUI examples that Simon showed. You could see that, I don't know, there was some zooming going on or whatever, and this axis on the side, it jittered around a little bit when the zoom level changed. And that's because if you do not manually interact with the axis, this timer doesn't play a role, and then it immediately resolves the layout whenever you change something about the limits. So if there's some other slider that you use to control the limits and the axis changes its labels, then it will just jitter around whenever the layout resolves. That's pretty annoying. You can disable that. You can just say, you can use another align mode where you say, I don't care how large the protrusion value is there and so on. But yeah, defaults matter, and mostly people don't change this stuff. And then I see I see this jittering a lot. Yeah, so that's one of the caveats. Yeah. Yeah, it also disappeared because the protrusions weren't quite correct. Exactly. The axis 3 just has, yeah, it has arbitrarily chosen default protrusion set, and those I picked just by trying what worked most of the time, but it's not great. And as you see with the rotation, it doesn't work better. So we're almost done. Okay? Things like then one more thing is the aspect ratios. I think people see that a lot, that if you give a certain aspect ratio via the aspect keyword to an axis, then you get gaps. And that's because there's no, you've seen what the layout knows, right? It only knows, is the width of an object inner width known or not? And what are the outer values? And there's nothing about an aspect ratio of a certain element that can be included. So in its current state, the layout just can't do it. And so the only thing the axis can do is shrink itself to the correct aspect ratio after the thing has already been solved. And that's how you get these gaps. And yeah, there can be cycles in the layout solving. So there's, if you have ever used auto limit aspect, what it does is it changes the limits of the plot given the aspect of the axis. And that's the cycle, because the limits change the axis labels, and the axis labels change the layout. The layout changes the size of the axis, and then the size of the axis changes the limits again. So that's a cycle, and it usually doesn't crash because the values are close enough so that the ticks don't change, but that's basically luck. So this thing, like if you ever get a stack overflow with auto limit aspect, that's the reason. And that's also something that is not great, but it is still useful enough to have this keyword for a lot of situations where you don't have a problem with this. But yeah, that's one of the caveats. All right, so the outlook. I would still, like, my dream is still to have at some point a constraint-based system that can more, like, where you can specify more things like aspect ratios across multiple levels or between different objects, and then it just does the best thing that it can, and it doesn't have to be perfect. Because right now the solution is deterministic, but it's not always perfect. Like, it's not always exactly what you need. And so I think that's the only way to go for me, because I think this kind of setup that we have, I don't see much way to improve like the core logic behind it. So the only way to improve it for some situations would be to make it less deterministic. But I'm not sure if that's great either. So maybe in the future there might be different modes that you can set on grid layouts, where you say like, okay, some subpart of the figure should switch to a constraint system or not. So yeah, that's a So for my all intents and purposes, the package is pretty much done, and I haven't needed to update it except for a couple of bugs in the last 2 years or so. But yeah, in the future that might be a bigger step that we can take. All right, now questions.
Yeah, questions. Let's do. Let's do 2 quick questions. Yeah. Wait. So the 2 comments are because I'm not super expert in Makie, so I understand that in this when you set aspect ratio and you have this color bulb problem, you set like percursion to a negative value to make it closer. So this is the solution to the issue.
You set it to a larger value so that the axis reserves more space.
No, but there was too much space.
Or between the color bar and the axis. You solve that by going, like, you set the aspect on the layout, not on the object itself, and then it solves it. Then it knows.
But could you set negative percursion to just make it mirror or not?
I guess you could, but I never liked that, because then you have to guess again. Like, if you change the figure size, it's wrong. And so the aspect, like, solving that with aspect sizes on the columns or rows, it actually works, but it's just not user-friendly enough. Like, people want to set the aspect on the axis and be done with it, but that's just not how the system works. And
yeah. Okay. And the second question with this cycle detection, couldn't you the same way as standard Julia display the cycle detection to just detect that you have cycle and then resolve it?
I mean, you can only, I think, resolve the cycle by really, you would have to solve like a mathematical expression, which in this case with the axis is probably relatively simple. You could say like, okay, I don't know, how much does the axis have to shift so that the label sticks out this amount that I want, and then you directly set that. But for an object like axis 3, where it's all about like 3-dimensional projections and rotations and so on, I think the math to predetermine that would be pretty annoying, and I'd have no time to look into it. So
no, but I mean that what is better, to throw stack overflow or to not to throw it and just produce something?
Oh, you mean, yeah. Probably one could do cycle detection and just break. It would just not be. Yeah, then you would have like the first iteration without.
Yeah.
That would probably be better. Yeah, I also have no time to do that. And so far, like, I go by the number of reported issues. So if people encounter this all the time, then it will already be solved. But I think I have seen like 1 or 2 persons in many years asking about it. So it has just slumbered in the code. Yes. So thanks for the question.
Oh, yeah. Maybe it's a little bit outside of what you showed here today, but can you maybe briefly comment on the relation between axis 3 and a scene object? Has it also to do with the protrusions, like when they try to align the axis or stuff like that? Because I'm always a bit confused by that. If you, for example, create a 3D scatter plot, you don't get an axis 3 out of it, but it's like a raw scene with some axis.
Oh, you mean why those are different? Yeah, that's like a historical it's a historical reason. So let me go back to this image. So the axis that we usually see if you draw like a scatter plot, which is not this one, right? It's the one where you have a scene and you can zoom around in it and so on. That was the first axis in 2D that existed for Makie. And that axis is just like a plot object. It exists in the scene and you can go circles around it with the camera and it will just behave like the plot itself. And this kind of axis, it was meant really for plots where it looks good next to the axis object. So it's supposed to look almost exactly the same. But and it's supposed to always, as you can see, the outer lines, they stick exactly to the scene boundaries. And you can also set it such that the corners here would stick to this and this corner. So I wrote it so that it always fits in a pre-described way perfectly into the rectangle that it sits in. And that's also why you can't fly around it, because that would break the thing. You can only rotate. And then people ask me like, why can't you? I want to zoom around in it. And it's like, no, the whole point of existence for this thing is that you can't. That it always looks good in layout, and for the other things, use the other axis. That's the reason why those exist and why they behave differently. Oh, something broke. Okay, good.
Thank you, Julius.
Thanks for the question.